Okay guys, let's have a look at question 4 now. For A we're going to do first. Here's the question. We've got two spheres. One of mass 3 kilograms moving with 8 meters per second on a smooth horizontal plane collides with another sphere of mass 7 kilograms moving with a speed 5. So let's draw them first. They're moving on the set plane in the same direction. Yeah? Okay, so let's draw them first before we get any more information. So it was two spheres, wasn't it? One of mass 3 kilograms, that was sphere A, and that was moving with a speed of 8 meters per second before the collision. Then you've got a sphere of B, and this is of mass 7 kilograms. Yeah, and this is moving with a speed of 5 meters per second. Right? The coefficient of restitution is 0.4. Let me just put that down then. Equals 0.4. So after the collision, this one will be moving with velocity. We can label that as VA, and this one will be moving with velocity VB. So, okay, so let's just look back at the question and see what it wants us to find out then. That's all the information we've got. So let's go back to the actual question. So calculate the speed of A and the speed of B immediately after the collision. Okay, good. So let's have a go at that then. So, conservation of momentum. Let's use that first. Gives. So the momentum before. So m3 times 8 plus 5 times 7. In this direction, wasn't it? Is equal to the conservation after, which is 3 VAs plus 7 VBs. So that's good. So that gives us 3 VA plus 7 VB. Reading from right to left is 24 plus 35. 24 plus 35. 24 plus 35. 59. 59. That's equation 1. Now, using our coefficient of restitution then, the 0.4 is the value of the speed after in this direction using restitution property gives, so 0.4 will equal the value after, which is VB minus VA, divided by the speed that they go together by, yeah? Which would be 3, 8 minus 5. So that tells us that VB minus VA, that's a 3, move that up, 3 times 0.4 is 1.2. So that's number 2. So we've got, so let's times, so 3 VA plus 7 VB equals 59. Then do 2 times 3, yeah, all the way through, to give us 3 VB minus 3 VA equals 3 of those, which is 3.6. You can see why we've done that now, can't you? Yeah? So we're going to get, what we're going to get, the reason we tripled that was because this would then be minus 3 VA, and that will then take away and disappear when we add the equations. This was equation 1, this we can label equation 3, and then 1 plus 3 then gives, so this will be 10 VB is equal to 59 plus 3.6 is 62.6. So that tells us that VB is equal to 6.26, isn't it? Meters per second. Okay, meters per second, VB. Okay, so that's that piece of information done. In the question, calculate the speed of the ball when it first hits the floor. No, sorry, calculate the speed of A and the speed of B immediately after collision. Okay, so we just need to get VA now. So let's sub it into either 1, 2, or 3. The easiest one to sub it into is this one here, isn't it? Equation 2. Sub into gives, so I'll put it down on the bottom line here. VA will equal VB. I'm going to move the VA over there and then the 1.2 over there. 0.2, which is 6.26, minus 1.2, which is 5.06 meters per second. Alright then. Yeah, that's 4A done then. Conservation of momentum and the restitution, the coefficient of restitution we invoked there. Those two properties gave us as pair of simultaneous equations essentially, and we just solved them to get the velocity of A and the velocity of B after the impact. So that's 4A done then. Good. So let's move on to the next one. Next part of the question. Great.